Imagine a weapon that was officially dismissed as too expensive, unpatriotic, and useless in the mud. Yet it was this very machine gun that made French generals blush with shame when their own perfect designs literally fell apart in the hands of their soldiers. You are about to discover the scandalous secret the French High Command hid behind their criticism of this weapon, and why the Japanese, the first to truly appreciate its power, kept the blueprints of this foreigner as their top military secret for decades. Did you know that in the midst of the bloodiest slaughter in human history, soldiers directly disobeyed orders just to get their hands on this specific model? Today, we reveal the story of the gas titan, the Hotchkiss machine gun. The late 19th century in military history can easily be called the age of the Maxim. Hiram Maxim didn't just create a weapon, he established a standard that seemed unshakable. His system, powered by short recoil barrel energy, dominated the minds of generals across Europe. It seemed that anyone attempting a different automated scheme was doomed to failure or oblivion. However, it was precisely in this atmosphere of total ideological dominance that a project was born which didn't just challenge the king of machine guns, but laid the foundation for all small arms of the next century. The history of the Hotchkiss isn't just a chronicle of creating another clatterbox, it's an international detective story intertwining the fates of Austrian aristocracy, American pragmatism, and French industrial elegance. It all began with a man whose name is rarely found in history books today, Baron Adolf Odkolek von Uyed. This Austrian designer possessed a truly revolutionary vision. While everyone else was trying to force the barrel to move backward for reloading, Odkolek asked, why not use that colossal energy of powder gases that literally flies out the tube behind the bullet? The idea of tapping gases through a hole in the barrel was radical and terrifying for its time. It required a fundamentally different approach to materials and precision, as hot gases under immense pressure are an aggressive environment, capable of quickly destroying a mechanism. Odkolek developed a prototype, but conservative Austria-Hungary was in no hurry to invest in a risky novelty. Eventually, the patent and the idea passed to the Hotchkiss company based in France. Here, two Americans took charge, Lawrence Binet and his colleague Henri Mercier. They transformed the raw idea of the Austrian baron into the perfected instrument we know as the Model 1897 and later the 1900. It's important to understand that Benjamin Hotchkiss's enterprise, though located in Saint-Denis near Paris, maintained an American spirit of rationalization. They didn't just want to make a machine gun, they wanted to make the anti-Maxim. If Maxim offered a complex device with water cooling and many small parts, Hotchkiss bet on simplicity and grim functionality. When the first Hotchkiss samples were presented to the Commission in 1900, experts were stunned by how its heart actually worked. Powder gases, having traveled almost the entire way down the barrel and nearly finished their job of accelerating the bullet, hit a small transverse hole. Through it, part of the gases rushed into a special gas cylinder located directly under the barrel. Inside this cylinder was a piston with a rod. The impact of the gases on the piston head was sharp and powerful, throwing the entire bolt group back, compressing the return spring and ejecting the spent casing. It was an elegant solution that freed the machine gun from the need for a moving barrel, which theoretically increased accuracy and simplified the overall design. This approach made the Hotchkiss visually recognizable and technically unique. While Maxims looked like massive cylindrical tubs due to their water jackets, the Hotchkiss had a thin, predatory profile. But the lack of water presented designers with a new, almost impossible task: how to keep the barrel from melting during intense fire. The powder gases working inside the system further heated the weapon, and standard air cooling seemed insufficient. This is where one of the most recognizable features of this weapon was born, its famous radiator. Engineers decided not just to blow air over the barrel, but to turn it into something like a car engine. 5 massive brass rings with deep ribbing were fitted onto the rear part of the barrel, which faced the greatest heat. These radiator rings were meant to accumulate heat and release it into the atmosphere. Military officials of the time shook their heads skeptically. Can air really replace a bucket of ice water? But Benet's calculations proved correct. Air cooling didn't just work, it offered stability. The barrel heated to a certain point, after which thermal balance was achieved. The metal expanded just enough not to interfere with the bullets, but remained within operating temperatures even during very long bursts. It was a technological breakthrough that made the machine gun much more mobile and independent of water sources on the battlefield. In this union of technology and ambition, a weapon was born that would traverse the sands of the Sahara, the jungles of Asia, and finally choke in the mud of the Great War to prove its worth. But before that could happen, the machine gun had to solve one more fundamental problem: the feeding issue. The cloth belts that Maxim loved so much found no place in the Hotchkiss design. Here, the engineers decided to go their own, even more original way, creating a system that simultaneously invited admiration and controversy. But more on that in the next part of our investigation. The transition from concept to real combat required Hotchkiss designers to solve a riddle that stumped many gunsmiths: how to ensure a continuous supply of ammunition if you strictly refuse to use canvas belts. In the late 19th century, fabric belts were the standard, but they were also a machine gunner's curse. If such a belt got wet in the rain, it swelled, causing jams. If it got dirty in thick trench mud, Maxim's feeding mechanism became a useless lump. Laurent Benet and Henri Messier decided their creation should not depend on the whims of the textile industry. The solution came in the form of a rigid metal cassette, or strip. This was a strip stamped from soft sheet brass, which was itself a masterpiece of engineering. To prevent such a thin plate from deforming under the weight of cartridges or during rough transport, special longitudinal ridges were bent along it to act as stiffeners. But the most interesting part lay in the locking system. 3 rows of tongues were punched and bent upward from the surface of the strip. These small brass tabs formed nests where the cartridges sat tightly and uniformly. Such a system ensured incredible positioning accuracy for each round relative to the bolts. Unlike a flexible belt that could twist, the rigid strip entered the receiver like it was on rails. For this mechanism to work, a series of holes were provided in the strip for the feed paws to grab. When the gunner inserted the strip into the left window, the machine gun began its rhythmic cycle and the empty brass strip flew out the right side. A standard strip held 24 rounds of 8mm Lebel. To a modern critic, this might seem insufficient, but in 1900 it was a reasonable compromise between fire rate and weight. Furthermore, designers provided for infinite fire. The ends of the strips had special hooks allowing them to be joined one after another during combat. Thus, an assistant could feed the weapon continuously, turning a 24-round system into a formidable stream of lead. However, the true pride of the Hotchkiss creators lay not in what they added, but in what they were able to remove. In an era when automatic weapon mechanisms resembled the insides of Swiss watches with hundreds of tiny screws, springs, and pins, the Hotchkiss seemed the height of minimalism. The entire construction consisted of just over 30 main parts. This was achieved through the brilliant use of the self-locking principle. Most units were joined together without screws, making the gun incredibly resistant to vibration. Screws tend to loosen from the shaking of gunfire, but in the Hotchkiss, this problem simply didn't exist. To maintain the weapon, the crew didn't need a toolbox. The only wrench provided to gunners was used to unscrew the barrel and gas cylinder. Everything else was disassembled literally by hand. An experienced soldier could strip the gun for cleaning in just 10 seconds and reassemble it in 12. This was critical in combat. If sand got inside or carbon buildup became too thick, the gun could be revived in moments. But even more important was the foolproofing. The geometry of every part was calculated so they couldn't be joined incorrectly. If you tried to insert the bolt or feeder the wrong way, the mechanism simply wouldn't close. This saved thousands of lives, as in the heat of battle, when hands shake from adrenaline, making a mistake is easy. Yet among these 30-odd parts was one that caused the most debate and mystification among experts: the gas regulator. It was located at the front of the gas chamber and looked like a small valve or tap. Many contemporaries mistakenly called it a hydraulic rate regulator, believing it was meant to make the gun fire faster or slower. In reality, it was much deeper. This regulator was the key to the weapon's reliability in extreme conditions. The principle was simple. The regulator changed the working volume of the gas chamber. Why was this needed? Imagine fighting in extreme cold where powder burns differently, or using old cartridges that provide less pressure. In such cases, the automation might lack the energy for a full bolt cycle, causing a sluggish extraction. In this situation, the gunner simply turned the regulator a few notches, reducing the chamber volume. The gases, compressed in a smaller space, gained more destructive force and pushed the piston back with double energy, making the mechanism work sharply. If the situation was the opposite, fresh ammo, heat, and perfect lubrication, the gun might start working too aggressively. Powerful bolt impacts at the rear caused the receiver and stock to shake violently, ruining aim and wearing out the metal. Then the regulator was unscrewed, increasing the volume. The gases expanded in a larger space, their pressure on the piston dropped, and the gun began to work smoothly, almost like a sewing machine. This allowed the crew to tune the weapon to the current moment, ensuring an ideal balance between reliability and shooting comfort. Despite this technical elegance, the Hotchkiss remained an outcast in its own country for a long time. The French military establishment, steeped in nationalism, struggled to accept that their primary automatic weapon was designed by foreigners. They looked for any excuse to discredit the system, complaining about high costs, lack of part interchangeability, and even the fixed fire rate. But while officials wrote reports, the Hotchkiss was about to face a test that would leave no room for debate: the test of mud, blood, and time.
When the Hotchkiss finally took its technical shape, military strategists faced a question as important as fire rate: how to move this 30-kilogram steel beast across rugged terrain. In the early 20th century, mechanization was a dream, and muscle power remained the engine of war. To transport one Hotchkiss, its massive tripod and numerous boxes of ammo, 2 sturdy mules were required. This was an entire logistical unit. One pack carried the gun body, another the folding tripod. This setup made the crew autonomous, capable of traversing mountain trails or dense forests where no wagon could pass. It was in these harsh conditions that the gun began to prove its worth. While French generals in cozy Paris offices grumbled that the Hotchkiss was too expensive, the weapon began its global expansion. Among the first to truly see the potential were the Japanese. Before the Russo-Japanese War of 1904, the Imperial Army bought a significant batch. In the dust of Manchuria, the air cooling proved superior. Japanese soldiers didn't need to find scarce water to cool barrels. The gun worked as long as there were strips. The Japanese were so delighted they didn't just keep buying, they created their own clones that became the basis of their machine gun park for decades. However, the real exam came in 1914 with World War I. This was a conflict of unprecedented cruelty and, more importantly, unprecedented mud. Battlefields turned into a slurry of clay and soot. This is where the difference between theoretical superiority and practical reliability became clear. The French army entered the war with Saint-Étienne guns, a failing rework of the Puteaux system. These were the height of complexity, a mess of open gears and springs, making them look like clockwork. On a clean range, they were fine, but in the trenches? One French soldier later wrote that in the sticky slime they lived in for months, everything failed. The famous Chauchat guns jammed after the first shots because mud entered the open magazine windows. The Saint-Étiennes choked on grit. Only the Hotchkiss kept firing. Its closed receiver and simple gas piston system were incredibly resistant to dirt. Soldiers on the front lines literally begged command to replace their finicky standard guns with Old Man Hotchkiss. Fortunately, there were separate companies armed with this model, and they were rushed to the most critical sectors. Interestingly, during this period, another unique feature emerged. The brass strips, once criticized for low capacity, became an advantage in trench warfare.
It was easier for the gunner to control ammo consumption in short bursts and for the assistant to reload by simply sliding in a new rigid pack. This eliminated the kinks often seen in Maxims when fabric belts twisted in the chaos. Moreover, rigid strips were easier to clean of mud before firing. A simple wipe with a rag was enough.
By 1916, it was impossible to ignore the obvious. French command finally admitted the defeat of their national school of design to the pragmatic genius of Binet and Odkolek. The Hotchkiss Model 1914 became the primary heavy automatic weapon of France. It was produced in massive quantities, a triumph of common sense over bureaucracy. The gun called Too Original in 1900 became a synonym for reliability. It feared neither hours of shelling, nor lack of grease, nor freezing winds. Its stable rate of 450 rounds per minute, once seen as a flaw, was now called solid and economical. It allowed for aimed fire without turning the barrel into a useless white-hot mass after a minute. The 5 brass rings, darkened by soot and time, became a symbol of French infantry resilience. But the Hotchkiss story didn't end in Europe. While it held the line at Verdun, its engineering genes were already sprouting in other designs, preparing the ground for the next technical revolution. The world realized the future belonged to gas, not recoil. By the end of World War I, the Hotchkiss had ceased to be just a weapon. It became a symbol of technical truth. When the smoke cleared, experts analyzed the experience. The verdict was clear. The concept laid by Odkolek and polished by Binet was more viable than most competitors. The strange foreigner with 5 brass rings ended the war as one of the most reliable tools of the infantry, but its true influence was only beginning to unfold. The main achievement of the Hotchkiss was the final validation of the gas-operated scheme as dominant for automatic weapons. Before this, many engineers thought using powder gases was a dead end, leading to overheating and fouling. Hotchkiss proved them wrong in practice. Other great designers followed. The second major player using a similar scheme was the Colt machine gun, developed by the legendary John Browning. Although their mechanisms differed in detail, the principle, gas pushes piston, piston moves bolt, became the gold standard. In the post-war years, the Hotchkiss continued its service across the globe. It could be found in the sands of North Africa, where French colonial troops valued its ruggedness. In the desert, where water was more precious than gold, the air cooling gave a decisive edge over any water-cooled system. It didn't need scarce liquid, and sandstorms couldn't paralyze it as easily as more complex rivals. The fate of the Hotchkiss in the interwar period was equally interesting. Despite lighter and faster models appearing, the trusty M1914 remained in service in many armies. Poland, Brazil, Mexico, China, the geography was impressive. Even in the Spanish Civil War, Hotchkiss guns were used by both sides, confirming their reputation as the weapon for the toughest conditions. Its longevity was explained by that very simplicity of 30 parts. It turned out that in a world where technology becomes more complex, the ability to fix a gun with one wrench and a rag is valued above all. However, progress didn't stop. By the 1930s, it was clear that the era of heavy tripod-mounted guns requiring mules was fading. War was becoming more mobile. Tanks and planes appeared, requiring higher fire rates and compactness. Here, Hotchkiss showed its flexibility. Large-caliber aircraft guns and AA units were built on its base. For example, the 13.2mm Hotchkiss became a common close-range AA weapon on ships and armored vehicles worldwide. Concluding the story of this amazing weapon, one cannot ignore its cultural and technical footprint. Hotchkiss taught gunsmiths not to fear radical solutions. It showed that a rigid metal strip could be effective, that air cooling wasn't a myth, and that simplicity is the ultimate sophistication. Those 5 brass radiator rings, which today look like steampunk aesthetics, were actually a manifesto of functionality. The Hotchkiss only left the stage when general-purpose machine guns, combining heavy power with light mobility, arrived.
But if you look at a modern machine gun or assault rifle, you will almost certainly see the same principles once proposed by an Austrian baron and realized by Americans in a French factory. The gas piston under the barrel is a direct legacy of the Hotchkiss, continuing to serve today. The story of this weapon is a reminder that true innovation is often born at the crossroads of cultures and against the popular opinion. The Hotchkiss didn't just fire, it paved the way for all 20th century weaponry, remaining a model of how engineering genius can turn the raw energy of powder gases into a precise, almost musical rhythm of perfectly functioning metal. And although other legends have taken its place, the Hotchkiss remains in history as the gas titan that wasn't afraid to challenge Maxim himself and emerge victorious.